Okay, so let's discuss right now in the area of low airflow evaporator. One of the biggest signs you'll get of a low airflow on the evaporator is what? Let's look inside the copper tubing of the evaporator. We have a saturated mix of vapor and liquid. We have energy going into it. Remove some of that energy, that heat, from the room going into the tubing. Now, what do you think is going to happen to the pressure in it when you remove some of the energy going in it? So with the low airflow, you're going to get low pressure. Okay? Without that much heat going into it, you're going to get more liquid coming down. So you're going to get less superheat. Less energy, less airflow, pressures go down, and what goes down? Energy goes down, right? So your superheat goes down. You can even end up with bad enough airflow from a dirty evaporator with liquid getting in the suction line going back to the compressor, which is dangerous. It could cause the compressor to go out. Over here, you have less heat coming out of the refrigerant because you have less heat going in it. So your subcooling is going to what? What's going to happen to your subcooling, do you think? It's going to increase. More liquid in here because of less hot vapor. Of course, with your pressures, your amps are going to go down. And what do you think is going to happen to your delta T? Well, with a delta T with low airflow, both of them, this could go up and this could go up almost exactly the same. So I'll say it's almost, it could be normal. Okay? That's why I say we don't check units by delta T. They could be very confusing, depending on what the system's doing. So with airflow, less pressure, the temperature, with the pressure down, remember what we said, pressure up, pressure down, temperature down. If we go down in pressure here, we go down in temperature, that coil's gonna freeze. So a dirty enough filter, or a dirty coil, or a bad fan motor, all of these things can cause a frozen coil. And you'll be like, well, if the evaporator's covered in ice, what do you think's gonna happen? It's gonna get a colder air going in the room. Well, absolutely not, because this is not pure hard ice, it's full of air. And the air bubbles act like an insulator, okay? So that's what's going on in here. Now I want you to think about this. Guys all the time go up to a unit and say, oh, it's frozen. It must be low charge. Ooh, it's frozen, it's a low charge. Oh, I had a guy once in here who went out and worked with somebody and they went to the unit, it was frozen, they thawed it out, put more Freon in the system. Came back 2 days later, it was frozen, put more Freon in the system. Came back 2 days later, put more Freon in the system. All they're doing is overcharging that unit. They're not fixing the problem. So my student said, why don't you check the superheat and subcooling? What? He started laughing. Why are we going to do that? Maybe so we don't have to come back 10 times. So I just gave you the symptoms of a low airflow coil and a low charge. So what is the difference here? When we have low airflow, we have more liquid because we don't have energy going in, so our superheat is low. When we have a low charge, we have less refrigerant coming in, so it boils off faster and you have a lot more vapor to be heated, so you have higher superheat. Frozen coil. You check the charge, you got high superheat and low superheat, telling you what the problem is. So you'll know whether you should fix or go look for an airflow problem or add Freon. You see this right here? That's what saves you time in the field, understanding this kind of technical stuff right here. This is what's going to help you understand when your coil's frozen that it just doesn't need more Freon, okay? Most people call you up. They'll say, hey, my unit's causing problems. You're like, what's wrong with it? I think it needs Freon. Okay, so that's that. Now we got one more symptom we're going to go over, which is coming up in the next one.